networking. It is a huge topic, so better will be in the main highlighted points. Compulsory must know it, guys. So this is a networking basics. So here it is. We start. Better to start in separate page. Okay. Networking basics means like what is network? What is a network? It is interconnection of two or more devices. So you are connecting devices for a purpose is why we should connect the devices for communicating between them. Interconnection of two or more devices called a network. So why should we create a network? To communicate between the devices for a sharing of information, sharing of data, sharing of resources. So this is a simple one network it is. I created one network here by simply connecting the devices to the networking device. Okay, it can be a switch or it can be a hub. Okay, so from here to here, it is connected now. Then what is networking? Communication between the devices. Communication between the devices. For example, A is able to communicate B. It means because of this network connection. So they are communicating each other means communication between the devices, interconnected devices called a networking. Okay. So basic definition part. Okay. So here I created a network. For example, this is A1, B1, C1 devices are connected. So I created one network. This is my network. For example, I have same network like that. I have a multiple networks. I have a devices and these devices are connected and communicate. Okay. For example, A2, B2, C2, D2. This is another network. So both are different networks. For example, in your home, you have a devices and you are connecting these devices through your Wi-Fi router, right? You have a laptop, mobile phone, you have a desktop, all are connected to the Wi-Fi router. It means it is one network. Okay. So this is a one network, this is another network. But you want to make a communication between these networks, first require connectivity. How these networks are able to connect through the routers. Okay. Both are different networks, so they should connect it. So this is called a internetwork. This is called a internetwork. Connection of two or more different networks called a internetwork. And communication between these devices, communication between different networks, we call it as a internetworking. Internetworking. From A, I want to communicate to the B2. So then it is internetworking. How can I connect? How can I communicate? Because there is a internetworking connectivity is there. So here is the statements. Interconnection of two or more devices is called a network. The communication between two or more interconnected devices is called a networking. What is internetwork? Is a connection of two or more devices, two or more networks. That is an internetwork. Internetworking means communication between different networks. Like this. Okay. Here, to create a network, we need certain devices like a hub and switches to create a network. To create a internetwork, we need an internetworking device called a routers. the router which make a communication between different networks. So it is networking device. It's not only internetwork, also it is internetworking device. Okay. The networks, we are connecting the devices physically. Okay, we are connecting devices. It's like a physical connectivity. It is. So that is different ways we can able to connect. I show one way. Okay, different ways we can connect a devices called a physical network. It is connection of devices. So based on that, so there is a different physical topologies also there. What is the physical topologies? The different ways of connecting devices. The way of devices connected is called a physical topologies. Then what is this logical network or logical topologies? Even though devices are connected physically, and also we can make them logical connectivity. Okay, on physical connectivity, so we can make a logical network. Means we can group these are the system are physically connected, but this group of devices are logically different network. Okay, so like that. So it is based on your IP addresses, any logical addresses like IPX, SPX, AppleTalk kind of protocol. We use it to make a logical network. Okay. Once again, guys, what is a network? This is connectivity between the devices. So here it is. What is the physical topology? The way of devices connected. The way of devices connected. Guys, understanding? So what I'm saying?
Yes, sir.
And someone came just now. Prakati. Okay. Okay. So we know this physical topologies. Of course, it is in our both in your graduation and in our childhood classes also it is there. Okay, so we have a devices. I will connect in a different ways, and each way it is has its own purpose also there. Okay, so I have a devices, and I connect these devices to a backbone wire. Connecting these devices to a backbone wire. Usually they use a coaxial cable here. They use coaxial cable here. Okay. So just like, in our olden days, we have a cable TV network is there. So there is a cable TV, their station, like they receive a satellite, through satellite, they will receive as channels. Okay. So based on your subscription, what they will do it, they run the cable. Cost is always same for everyone. Okay. So cost is same for everyone, 50 rupees, 100 rupees per month. So they will run the cable from their station to the houses. Okay. They make one big cable. From that cable, so they will put a one junction box. From that one, they will connect to the different houses. In certain distance, the signal is weak. They'll use some repeater kind of stuff. Okay. So they use some repeater. So from that one again, they will extend the connectivity. Okay. So it is based on a backbone cable. From the backbone cable, the TVs are connected. It is the same formula for computers also. They use this what we can say coaxial cable. Okay. So computers are connected to the a backbone cable. So this is very easy to configure and installation. Installation configuration is quite easy here. Okay. Okay. It's very easy to configure. All devices are communicating through this backbone wire only. For example, A want to send a packet to C, it has to go through this backbone cable only. So all devices are communicating through this backbone cable. Okay. So the point is here it is very easy to configure. Simply take a device, connect the device from their NICs to backbone cable. Okay, easy to configure, but difficult to troubleshoot. Of course, it is a cheaper, but it's difficult to troubleshoot. Why? Because of if this backbone cable is damaged in certain place, okay, at some point this backbone cable is damaged. The further communication will stop. From up to here, communication is there. From here, no communication. The communication will stop from here to here. Okay. That is and you have to trace entire cable. You have to trace entire cable where the cable got issues. Again, you have to repair the cable in that place. And once you are open the cable, distortion will occur. Okay. That is another problem. Okay. So this is what I am trying to say is it is a bus topology. It is a bus topology. So what is a bus topology? The devices are connected to a backbone cable. Devices are connected to a backbone cable is called a bus topology. The next one is here. So I faced some problem here. So then I implemented this topology. What is this topology? It is the devices are connected. One device is connected to another device. Another device is connected to another device. Another device is connected to another device. And last device is connected to the first device. It's just like a circle. Okay. It's like a circle. So A is connected to B. B is connected to C. C is connected to D. D is connected to E. Okay. It is form a ring. So that's why it is called a ring topology. So they use a certain algorithms like a ring, bucket ring topology kind of algorithms. So they will define how to communicate. For example, A want to send a packet to D, A to D communication. So you know how it is happen, A to B, B to C, C to D. Okay, only in a clockwise direction or anti-clockwise direction based on the configuration. D want to reply to A, D to E, E to A. The distance is automatically altered, so it is like this. Okay. So it is also very easy to configure, but you have to implement every system how to communicate. Once it is fixed, it's well and good. And it is also there is a few points. Okay. Thing is, if in case the C device is down, you can communicate A to B, E to B, D to B like this. But A to D we cannot communicate. B to D we cannot communicate. B to E we cannot communicate. B to A we cannot able to communicate. Okay. This communication is stuck. Either the one of the cable, connection of one of the cable is down. Okay. If this cable is down, still we cannot able to communicate. C can able to communicate to D, E, B, but B cannot able to communicate to C. A cannot communicate to C. Okay. See, it is simple. One cable is gone, so the communication, one side of communication will stop. Okay. So to avoid this thing, so what they have done, so there is next implement is double ring topology. What is double ring topologies? Means two connections between the devices. One connectivity is for clockwise, another connectivity for anti-clockwise. Okay. So what is happened? So B2D communication directly, A is like B to D. So B, C, D. D2B communication, DCB. Okay. So it's a double ring topology to avoid, and it is difficult to scale also. Difficult to scale. For example, I add one more device. Again, I have to change the connectivity. Again, I have to configure every system. So how to communicate? Okay. If you add one more device, it's again, you have to go to each and every device and you have to discuss about you have to configure about the connectivity, means how they should communicate. Okay, so it is easy to configure, but the point is difficult to scale. Like you cannot increase the size of, because again you have to go for each and every device to configure, and more number of devices increases, the more configuration in each device increases. Okay, it's difficult to scale. If you want to add one more, again you have to configure in every system. This is a ring topology. What is a ring topology? A device is connected to another device, other device is connected to another device, other device is connected to other device. Finally, the last device is connected to the first device. Like it is form a ring. Okay, so circle. Guys, understand what is bus topology, ring topology, and a star topology, that is mesh topology. Okay. So two topologies we discuss. Now everybody can able to answer this one, then we'll see. Which topology it is, guys? Anyone?
Star topologies.
So this is a mesh topology. We hear the star topology automatically. So we said this is star topology. This is not star topology. It is called a mesh topology. Okay. What is the mesh topology? It is every device is connected to all other devices. For example, A is connected to B, A is connected to C, A is connected to D, A is connected to E. Same way, B is connected to A, C, D, E. See, every device is connected to all other devices. What is the point of it is? It is a complex. Mesh topology is a complex to create because number of devices increases, number of connectivities are increases. Okay, we should not forget which two, which one. Like 4 or 5 devices are there, so we can able to understand we are connecting cables. More number of devices, it's become very complex. Okay, more connectivities are required. Each device required more analysis to connect. Okay, but what is the advantage of mesh topologies? Okay, so bus topology, easy to configure, difficult to troubleshoot. Of course, difficult to troubleshoot, of course, because we have to trace entire wire here. Ring topology, it's a parallel kind of, it's a configuration, every device is requirement. Of course, how to communicate, we have to define the communication. Of course, easy to connectivity, configuration is also okay, but difficult to scale, and it's a difficult to scale. But problem is, like if any one of the devices down in ring topology, further communication will be stopped. Okay, one side communication is there, other side maybe communication will be stopped. So it will confuse which device is really communicating. So it's difficult to trace the issues also. Even mesh topology, same thing. But mesh topology starting, it's complex because more connectivities are there. Okay, number of connectivities between the devices are higher. But there is advantage in mesh topology that is called a redundant. It is a redundant. What is a redundant? For example, if this cable is down, but remaining communication going on, A to E, A to D, A to C communication is going on, B to E, B to D, B to C communication is going on. Only A to B communication is stopped. And maybe a device is down, like C is down. All remaining devices will communicate. Okay, it is a redundant. Okay, it's like a failure type. Okay, so what is that meaning is, even a one of the device is down or a cable is down, but remaining devices will communicate each other. Of course, configuration is complex, but it is redundant and difficult to scale. It is, again, one more is there, that is difficult to scale. What is a scale? What is meant by scaling? Ability to increase, either it is increasing your network or infrastructure, okay, like extending. It is very difficult to scale. See, for example, if I add one more device, again you have to do all the connectivities. Unlike ring topology you have to do configuration also, but here it is, you have to do lot of connectivities. Okay, it's difficult to scale, difficult to troubleshoot also. So mesh topology is complex, difficult to scale, difficult to troubleshoot, but it is redundant. What is meant by redundant? If one of the device or a cable is disconnected, we cannot able to come. Okay. So for remaining communication is going on, only the down device or a disconnected connectivity only won't work. Remaining is function happy. That's it is redundant. Okay. One important is, yeah, this mesh topology, of course, bus topologies, ring topologies, we are not at all using any kind of network related. Right now, we are not using bus topologies, ring topologies, as I know, nowhere we are using. Okay, but mesh topology is still using only in some core networking places. Means I have a multiple routers. Between the routers, one router is down, but another routers should be given communication. So then they'll create a mesh topologies. SAN storage networks. Storage area network is then SAN storages, centralized storages used in enterprise organizations only. So that is a storage connectivity. So storage devices are there, storage servers are there, storage related switches also there, like a fiber optical switches are there. So they use the mesh type of connectivity. Means a one device is connected to multiple switches. Okay, it's like a full mesh topology type. Means mesh and star topology combined. It's a kind of hybrid topology, but still it is a they use this mesh concept. If one of the device is down, still we can able to access things from the other device. Okay, other device connectivity is there. So this is the mesh topology. Mesh topology is a complex, difficult to scale, difficult to troubleshoot, and it is redundant. So then this mesh topology is used in certain places like main data centers, okay, storage, SAN type of storage places, okay, core networking places, they use this mesh topology. Understand guys, what is the mesh topology? So what is a mesh topology? One device is connected to all other devices. Okay, this is actually star topology. This is a star topology. Why it is a star topology? This is the what is a star topology? So devices are connected to a centralized device. Either it is the centralized device can be a switch or a hub. A centralized device is can be a switch or a hub. The devices are directly connected to centralized device. It is easy to configure. Of course, this is a star topology where somewhere I have to write. This is a star topology. What is a star topology? Devices are connected to a centralized device. It can be a hub or a switch. and devices are communicating through this centralized device only. For example, A want to communicate it to B, it has to be communicated through this centralized device only. A communicating to F, it has to be communicating through this centralized device only. Okay, it is easy to configure, easy to configure, easy to troubleshoot, easy to configure, easy to troubleshoot. Any one of the device is down. For example, if D is down, communication won't stop here. Remaining devices will communicate each other. Or wire is broken. For example, this wire is got a problem, means it's broken. Only C cannot able to communicate. Remaining will communicate each other. Okay. But thing is, if in case this centralized device is down, total communication is down. Because of this centralized device, it is additional cost also. See, bus topology, ring topology, mesh topology, we are not used any additional device here. Only we use cables. But here we are used additional device. So that's it's a additional cost is also applicable. Additional cost is also applicable in star topologies because additional connectivity device we are used here. But there is a lot of advantage of star topologies. One is easy to configure, easy to troubleshoot. How? If this device is down, if D device is down, okay? So in the hub RS switches, there is a LED indication, it shows off. So it means we can understand, so the connectivity related or device related issue, immediately we'll understand, okay? So that's why it is not communicating. Like that, we can able to understand. Easy to configure, easy to troubleshoot. One more is easy to scale. Easy to scale. Okay. It means you have more number of devices required. For example, in your organization, you have a 30, 40, 100 computers are there, 200 computers are there. Still, we can able to connect as a single network. You can connect all the devices as a single network. Okay, how it is possible? Because it has some extending properties also there. It means simple scalability. What is the scalability? Ability to increase the size either horizontally or vertically. It means nothing. Okay. For example, this is I have another devices. What I can able to do it, I can connect these switch to switch or hub to hub. So what happened? It extended. Now I got a more devices connected in the single network. This topology we call it as a extended star topology. This one is star topology. This is a star topology. This part is star topology. And this is also a star topology. And we connect both are like this. So then it is become extended star topology. So guys, the star topologies are easy to configure, easy to troubleshoot, and easy to scalable. No redundancy. No redundancy means if switch is failed, communication stops. Multiple devices cannot able to communicate. Make it simple. The connected devices cannot able to communicate. Okay. But one of the device is down or one cable is gone. So only that part of communication is stopped. Remaining is communicate. Okay. So this is extended star topology. Next one is hybrid. Hybrid means, as I said, mesh and star topology combined. Full mesh topology is called a hybrid topologies. And point to point, what is meant by point to point? A device is connected to another device, right? Either directly they are connecting or through the device it is connecting. It is point to point. Like a computer is connected to another computer, point to point. A computer is connected to a switch, point to point. Also, it is hybrid. Okay, this is point to point, pure point to point, computer to computer. Okay, for in a star topology, you see computers are connected to this one. So itself a star topology, but still it is point to point. This small example. The original point to point is like a device is connected to another device is a point to point. Okay. Generally, where we call this point to point is a router in the one network, other router is in the another network. So if they are connected using a WAN connectivity, that is a point to point. So I'm in a head office, okay, and this is branch office. In a head office have an infrastructure, branch office have an infrastructure. Both side they should communicate each other. So I have a router here and I have a router here. So I create a WAN connectivity between them. So they are connected like this. This is a point to point. That is point to multi-point. Point to multi-point. For example, I have one head office where main infrastructure data center is there. So from that one, I am connecting to multiple branch offices. Okay. In globally, I have a multiple branch offices or the WAN connectivity I am connecting. Okay. So, so that is pointed to multi-point connectivity. So the last one is tree topology. What is this tree topology, guys? The tree is not actually a topology, but recently people are telling this tree topology. So that's why I added this one. Okay, main topologies are bus topology, ring topology, mesh topology, star topology, hybrid. Hybrid means combination of two topologies. Only these are the main topologies. Bus topology, ring topology, mesh topology, star topology, and hybrid topology. Okay. Remaining are just additional one. Okay. Of course, you can able to tell that one also. What is a tree topology? If you see, there is a backbone wire. There is a backbone cable. To this backbone cable, different topologies, like it is a hybrid type only. See, this is a ring topology directly connected. So sorry, this is a star topology. This network is connected to backbone wire. This server is connected to backbone wire. And this is extended star. It is, see, it is connected from here to here and it is connected to it. So it become a common communication point. Okay. It's a kind of hybrid, but so like a tree means the different networks are connected to a one common backbone cable. Okay. Just like your Reliance network is also used that kind of stuff also. Just for you, I don't add what happened. I did it here. This is a bus topology. Device is connected to that I will write in a bottom or a top. So either it is a bus topology. Devices are connected to a backbone cable. Usually they use coaxial cable. Okay. So what is another point? It is easy to configure and difficult to troubleshoot. Okay. If backbone cable is broken, further communication starts. Okay. Ring topology. What is the ring topology? How to write? A device is connected to other device, another device connected to other device. Okay. It's like one. The last device is connected to first device. Okay. This is also easy to configure. Okay. It is. So somewhere I have written some another device, the first device, another device. Okay. It is easy to configure, difficult scale, and if any device or connection is down, one side of communication stops. Yeah, I've written like that, but you may understand what is the exact meaning. Okay. Because you have to explain if in case if they ask what is that one side of communication. Okay. Okay. Devices communicate either either clockwise direction or anti-clockwise. Depends on configuration. But that much not required. Just this point is important. That is how it is connected and what is the advantage, disadvantage. That's it only. I added a point only. Mesh topology. What is mesh topology, guys? Anyone please help me? Every device is connected to all other devices. Okay. Complex to configure. Difficult to not default. Why it is default came? Difficult. Difficult. Here it is also difficult to scale. Auto correction affected. Difficult to scale. It's difficult to troubleshoot. Plus a lot of connectivity is there. And main important, difficult to scale. Okay. But redundant. Okay. What it is? redundant mesh topologies used in core networking places, servers, and storage networks. Yes. Star topology. Finally, we got into the star topology. What is star topology, guys? Every device is connected to a centralized device. I done some mistake here. Centralized device, difficult to scale. Every device is connected to centralized device, which is either hub or hub or switch. Either it is hub or a switch. Devices communicate through the centralized device. Through the centralized device. Okay. If any of device or connection is down, the devices communicate each other. Communicate each other. If centralized device means it can be hub or a switch is down, all communications stop. Okay, here also there is a point. Same point here. If any device or a connection is down, other devices communicate each other. Easy to figure. Easy to configure. Easy to troubleshoot because the switch or hub has a LED indication that will tell so which device is disconnected or which device is down. So we'll understand one device is not communicating means either device related or maybe connectivity related. Simply can go to the switch and check it the LED status and we can find it. So that is the point. Easy to configure, easy to troubleshoot, and easy to, and it is scalable. Okay, it is scalable. Means we can extend network size. Okay, that is called an extended startup. What is meant by hybrid? Combination of two or more topologies called hybrid. So I'm giving an example here. Is like an example, full mesh topology. Used in LAN. Full mesh topology. Used in SAN. That is like both, it is used for star as well as a mesh. Okay. You guys understand all the topologies? Bus topology, ring topology, mesh topology, star topology. Hmm. And people gone also. What happened? No one is saying anything. Told very small topic only, physical topologies. If you don't understand, also tell me, just I will explain once again. Or maybe I will explain in different way. What happened? No one is responding. Hmm? Guys?
Un- Understood, sir.
Okay, good. Okay, so we'll see. So actually, I want to tell this part as separately, but I'm going to explain this right now. So then we'll take a break. Okay. So another one is types of network. So based on the way of connectivity, we define these networks like a physical topologies. What is a physical topology? The way of devices are connected. So you can maybe connect devices to the backbone cable, or maybe you are connecting one device to another devices. You are connecting one device to all other devices, or maybe you are connecting devices to a centralized device. This is the way of connectivity. We define those things as a physical topologies. Devices can be connected anywhere, but as per the textbook, as per the geographical range, so there is a different types of networks also there. For example, I have a room. In the room, I have a devices are connected, and I call that network, we call it as a LAN network, a LAN network. Or maybe I have a floor in the building. I have a one complete floor. All are my devices only. All are connected. All are connected. So, and I that is also a LAN network. That is also all network. This is a my private network. It is my local area network. Maybe I own the building. Okay, entire this building, and the building has different floors. Okay, and my employees are working in a different floors, and I connected them and create a network as a single network. So that's it is, I am calling that one as a single LAN network. So the LAN, as per the geographical size or a range, It can be a single room, it can be inside a single room, or it can be entire floor, or it can be entire building. So that is what we call it as a LAN range or a LAN search. Okay, as geographical point of view only. The original meaning of LAN is different, but I'm not talking about that original meaning. This is just based on the textbook. Okay, a single floor, single floor or a single room or entire building, you can make them as a single LAN. I want to add one start point here. It is we are using star topology in our okay. We are using star topologies. Next, campus area network. For example, I'm a bigger organizations, not only one building. I have a multiple buildings networks are there. Each building is one LAN network. Each building is one LAN. You take college campus, university campus, bigger organization related campuses also there. For example, you can say Tech Mahindra campus, HCL campus, or Cognizant campus. So like they have multiple buildings for a different department purpose. Take example from college, ECE department, Triple E department, okay, CSC department, okay, mechanical department. So then each department has their own building. Think like there are has a one LAN network. Each one, the range one is a LAN network. And you started like a this IT department and mechanical department should communicate each other. So there then you are make a network connectivity between these devices, these LANs, and it created a very big network. You created a very big network by connecting these different LAN networks. You created a big network. And the range of communication is within the campus only. This is a one LAN network, that is another LAN network, another LAN network. But you combine all these LAN network and make it a one big network. So then these department people can communicate each other. For example, CSE people require some information from the IT department, or maybe some mechanical department, maybe a civil department. So they need to share some information, say share documents, or maybe they need some software support from others, or maybe some measurements or project ideas. So like that, they want to get some information. They should require to communicate. So then we connect them and make a single network. Okay, so we can make them communicate each other. So within the campus only, within the campus only. So that is called a campus area network. Campus area network. Understand, guys? Campus area network. Next, no one is okay. In a city, in a city, also we have a different departments, right? In the city, campus area network limitation is within the campus communication only. We cannot communicate outside or inside again. As within the campus, you can communicate. That's the geographical range of campus area network. Within the city, we have a different departments. So, fire department, hospital department, mayor offices, okay, road transport departments, people, organizations also working in a different things, right? So there is a different types of people, not the regular people are there, and as well as organization level networks are there, right? So they have their own LAN networks. They have their networks also there, right? Department wise network. Okay, so different networks are within the city, and you combine, you connect all these networks together and make it as a very large network. We make it that one as a very large network. and they can communicate each other, so they can able to share information, data like that. For example, I want to see my electricity bill. Is it paid or not? So I can able to get it within the network only. So I don't require to download from internet. Not everything not required for the internet. So within that place, whereas court is there, required a document from police station. So they can download it from like that. That they can easily communicate. They can share information. They can share resources. So they can share these documents kind of stuff. Okay, they can inform some points about reporting kind of stuff like that. So people can able to communicate each other with the different networks to combine, and they can communicate each other, but within the city only, within the city limit. So that is what we call it as MAN, Metropolitan Area Network. It is why it is called a MAN, Metropolitan Area Network, because initially, because this city is a metropolitan cities, bigger the cities. Okay, so not in a village, so they don't use computers, so they don't require this much of data transmission is not required. So it's a simple villages, smaller the sizes, not required much the sharing kind of stuff. So when there is a metropolitan city, so they implemented initially they implement in the metropolitan cities the city-wide network. Okay, city-wide network. Okay, California metropolitan city. So that's within the there people can communicate with each other. They can share resources with each other. Okay, so guys understand LAN, CAN, MAN.
Yes, sir.
Here it is. I have a main office in New Jersey. So there is a network in the New Jersey. Okay. And I have a branch offices in Hyderabad. I have also having a network in a Hyderabad, right? This is a network is there. I have a servers kind of stuff is also there. Here also I have some database servers kind of stuff is also there. Now, like that, I have a different offices in globally distributed. For example, this is in the Sri Lanka, for example. Okay. So what they will do it, so that is they require to communicate between this office network to this office network, this office network to this office network, this office network to this office network. But how they can able to communicate both are geographically different places. Not they are not in the within the city, they are not in the within the campus, not in the same building. There are different geographical locations. So what they will use it? They use WAN connectivity. Okay, the WAN connectivity between. What is WAN? Wide area network. What is WAN? Wide area network. What is the purpose of WAN? Connecting from one geographical location to another geographical location. So globally, we can able to communicate. The WAN over internet, over WAN over the public network. WAN is a private, but WAN over the private public is called internet. Now we are getting able to communicate google.com, facebook.com, youtube.com. All we are able to communicate through the internet only. It is also, internet is nothing but networks of networking. Globally, there are a lot of networks are there. We put all the networks connected via WAN connectivity and can able to access through the public network. Okay, so that is WAN over the public is called internet. And WAN is in a private type, means one organization located in some geographical location, and another part is located in different geographic location. We can able to communicate each other through the WAN communication, wide area network. Okay. So what is the LAN? Local area network. CAN, campus area network. MAN, metropolitan area network. WAN, wide area network. Okay. These are the main four networks are divided based on the geographical range or sizes. Okay. So here it is. I added two more networks called a PAN and HAN. Personal area network, home area network. There is, when I search, like people are asking, sir, what is PAN, what is HAN, what is BAN, what is SAN, what is CAN, like that. Okay. So out of that, I feel some 2 points are very interesting. That is called a PAN. It's a personal area network. Means you have a devices on your own, like you have a Bluetooth devices, like a Wi-Fi related Bluetooth devices. With that one, you can able to connect your smartwatches, smartphones, smart shoes, smart clothes. All you are able to connect and make them it communicate each other, right? So that is like a PAN, personal area network. You created your own network within your space on. Okay, the range is the personal range. Home area network within the home. It is kind of LAN only, but within the home you have a lot different types of devices: smart TVs, smart LEDs, smart ACs, smart home appliances. Where a lot of home appliances we are getting now. Alexa, Echo Dot, or maybe Google Home Next, Smart Plex. You can use simple Alexa and Google Home Next via written that one. You can simple giving some voice command. You can control the devices. Okay, if you want to turn on your AC, then you can give a small okay. So we can make them connected also. For example, I have a smart geyser is there, smart AC is there. So I said geyser on, so AC is off automatically. So like that we can configure it also. Okay, so smart appliances in a home, so we can create a network in between, and we can able to control them. We can command them, we can communicate them. So that is home area network, as I understand, because both are feel very interesting nowadays. Even smart printers also came, so that's like within the home we can able to go for the Wi-Fi printers, smart printers kind of stuff. Okay. So finally, guys, what is LAN, local area network? It is a private network. Okay. So these two are we don't mind about it. Only two are important. One is LAN and another is WAN. Okay, but the size like a can within the campus, LAN, local area network, of course, you know, it's a private, your own private network. It is within the office or within the building, within the home, like that. CAN is man, mainly 2 points, that is within the campus, within the city. WAN is a global network. It is not limited to the campus or a city. It is a global wide network. So from geographical location to another geographical location. Private to private, one private network to another private network. Over the LAN, WAN, we can able to communicate. WAN over the public is our internet. Yes, understand? LAN, CAN, MAN, WAN.
Yes, sir.
Yes, sir.
Okay. And two more points I will tell, and then we'll take a break. Only 2 points, these 2 points. What is intranet? What is intranet? I'm in my office. In my office, I have a servers, other computers also there. So I can able to communicate with them. Means it's a simple LAN network. I have my own computers, desktops, laptops, servers, devices are there. So I can able to communicate with them. For example, my web server is in my LAN network only. So it is intranet. Intranet means local and private network. Intranet means local or a private network it is. Internet is a global. So I want to access facebook.com. It is not in my office, right? Facebook.com is outside of my network. So I want to access facebook.com. I need internet connection. So global network, public, networks of network. Internet means so different networks in this world. So they're all connected and we can able to access over the internet. Okay, these two are so two important. So intranet, internet. Intranet means local, private within the LAN net communication. What is internet? It is outside of your network. It is a public network which you can able to access different kind of stuff, I mean, like google.com, facebook.com, gmail.com, okay, which is outside of your network, we can able to access through internet. Okay, that's the point. Okay, so I added this one for some people, but of course we can discuss other things separately. Yeah, take a break, guys. Now it is 11:45, so I have taken more than not more than 1 hour, but almost 1 hour. Okay, take a 15 minutes break. Come back at 12.
Okay, sir.